Today's lesson is on transformations of parent functions. In class, we talked about the basic features of a bunch of different parent functions, and then we're going to look at transforming them, so shifting them up, down, right, left, reflecting them, and then dilations like stretching them and compressing them. So let's say you start with this function f of x, and then we're going to do things to change this function. Maybe we will multiply something in front of f of x, and then maybe in its parentheses, we'll multiply something, and then maybe we'll subtract something away from x, and then outside of the parentheses, maybe we will add or subtract something else. We can add in these things to any of the parent functions that we've talked about. And depending on what you're adding and how you're adding it, it's going to change that parent function. Adding or subtracting something at the end of your function would create a vertical shift, shifting your parent function up or down. Adding or subtracting something inside the function creates a horizontal shift, right or left. And the horizontal shift you actually find by doing c divided by b. Now, in this lesson, most often our b value is going to be 1, but we just do have to keep that in mind. Sometimes we'll have a number other than 1. So it's not just shift c, it's shift c divided by b. And then the a and the b, if you're multiplying your function, you're going to stretch the function or compress the function and sometimes reflect the function. So the reflection will come from a negative a or a negative b. So now I'm going to take one of these things one at a time and apply them to some of our different parent functions. Okay, starting with a vertical translation. This is when you have a function and then you're just adding or subtracting something at the end. I do suggest if you have different colors, we're going to be graphing multiple graphs on the same coordinate plane here. So maybe have 3 different colored pencils, highlighters, just to organize your notes. I'm going to start with, let's just graph the parent function y equals absolute value of x. So that is just the v that's starting at 0 and has that slope up 1/1 in both directions. And let's do a vertical translation. So let's say we have the absolute value of x minus 5. That is simply going to shift your parent function down 5. So if we take the middle point, 1, 2, 3, 4, 5, move it down 5, the slope stays the same. And then you can just graph the rest of your function. Let's do one more. So this time I have a plus 3. That's going to shift my parent function up 3. So from the starting parent function, we're just going to shift all of its values up 3. And the idea is that you can apply this vertical translation to any of the parent functions. Okay, so now a horizontal translation is when you are adding or subtracting inside the function. Vertical was outside of the function, horizontal is inside the function. So this time we're going to use this function, this parent function y equals 1/x. So if you remember, it has vertical and horizontal asymptotes right at the x and the y axis. We have these points here, and then we can just sketch. Okay, so let's do a translation. Let's do y equals 1/x minus 4. So we're subtracting 4 inside, not at the end, but inside the function. When you have a minus, that is a horizontal shift to the right. So So let's think about, we're going to shift all of these to the right. What we're going to do is really shift our vertical asymptote to the right as well. 1, 2, 3, 4. Our horizontal asymptote will stay the same because there's no vertical shift this time. And then shift all of your points as well. Okay, let's do another one in the other direction. Let's do 1 over x plus 7. So when you are adding inside your function, it's a horizontal shift to the left. So we're going to change our vertical asymptote at left 7. Still has the same horizontal asymptote. So now get your points on here. So there we go. You can apply a horizontal shift to any of those parent functions. Okay, now we're getting into reflections. Reflecting over the x-axis is when you have a negative in front of your function. Okay, we're going to graph the parent function of the cubic function. Okay, so first I'm just going to apply the reflection, and then I'm also going to, with the reflection, add in a shift. So first, let's just graph y equals negative x to the third. So having that negative in front is going to reflect everything over the x-axis. So this point, 1, 1, is going to flip down here. 2, 8 will flip down here, and then negative 1 flips up. And then we still have that 0, 0. So here is what that reflection looks like. Okay, so now let's take that reflection and shift it. I'm going to do x plus 3 cubed minus 6. So I already have my reflection, so I'm going to shift this red graph. And I'm going to shift it. Let's see, that's going to go left 3, down 6. So taking the red graph and shifting all my points left 3, starting up here. 1, 2, 3, and then down 6 right here. Keep going. 1, 2, 3, down 1, 2, 3, 4, 5, 6. So you're going to have this graph. So you might look at this green one and think it looks really complicated, but if you just remember you got your parent function, then you can reflect it, and then you can shift it. Kind of take it step by step, and then it's not too bad. Okay, now switching gears and looking at reflection over the y-axis. This is when we have a negative in front of our variable inside the function, so not out in front of the function. For this one, I'm going to start by, let's do the square root function. Y equals the square root of x. So plot that parent function. We've got 0, 0, 1, 1, 4, 2, and 9, 3. And now let's do a simple reflection, and then I'm going to add in a shift to this one as well. So y equals the square root of negative x. The negative is inside that square root. So let's reflect over the y-axis. So I still have 0, 0, but now it's flipping this way. Okay, so now let's put some vertical and horizontal translations together with this. Y equals the square root of a negative in parentheses x minus 2, and then outside of the square root minus 3. So here is my reflection, and then here I am shifting down. But the horizontal translation is a little confusing on this one. I'm going to, let's think about this. I've got y equals, I'm going to distribute that negative in. So I want you to think of it as negative x plus 2. And then back to that first part of our notes where we had our A, our B, our C, and our D. The horizontal shift is your C divided by your B. So in this case, the C is a -2 and the B is a -1, which is a +2. So that's shifting it right 2. Normally when you see +2, you would think shift left, but then when you have that negative, what it does is it flips it back and shifts it right. So let's take the reflected red graph and we're shifting it right 2, down 3. All the points right 2, down 3. And there we have our graph. Okay, we've done translations, reflections, and now we're doing dilations. So a vertical dilation is when you are multiplying your function by some sort of scale factor. I always want you to think of like slope. You know, you've got y equals x, and then what happens when you have y equals 2x? You're changing your slope. You're making it steeper. So it's kind of that concept. Let's start with doing the parent function of the greatest integer function here. So I like to start by putting all my dots. And then we can do the horizontal parts and the open circles. Okay, so I'm going to do a vertical dilation and a horizontal translation all in one. So let's do y equals 3 times the function x plus 4. So this will shift left 4. And then this multiplier, in this case, if you think about like the slope is up 1 over 1, this is going to change the slope to up 3 over 1. So what I'm first going to do is shift kind of this starting point here. I'm going to shift it left 4. 1, 2, 3, 4. And now instead of up 1 over 1, I'm going to go up 3 over 1. Continue up 3 over 1. And I can reverse it. So notice how I am stretching. I'm doing a vertical stretch of the parent function, and I am doing a horizontal shift of the function. Okay, last example, a horizontal dilation. It kind of brings in that same idea of compressions and stretching. So this time, let's do the parent function y equals x squared. So we have our 0, 0, 1, 1, 2, 4, and 3, 9. Okay, for this one, let's do a horizontal dilation and a vertical translation. So y equals, in parentheses, let's do 2x squared, and let's go minus 5. So we can simplify this. We can do y equals 4x squared, and then minus 5. Well, starting with the vertex, because it's 0, 0, the multiplying by 4 is not going to change that, so I can just shift that straight down 5. And then for some of these, it's probably easiest to just plug in your values. So we've got our 1, 2, and 3. So plug it in. 1 squared times 4 minus 5 is -1. And Then when you plug in 2, 2 squared is 4, 4 times 4 is 16, minus 5 is 11. So this will go off our graph, but we can get 211 on here. So we have the shift, and then we have, this is a horizontal compression. It's like you're getting it, compressing it towards the y-axis. It looks very similar to a vertical stretch. But I'm not going to make a big deal about these words, just as long as we can transform our parent functions. So there's your full video on all the different transformations of some of our parent functions. Good luck with your lesson.